In this video, we will discuss very important concept with respect to sequential circuits. What is truth table in flip-flops? What is excitation table in flip-flops? How to derive excitation table from the truth table. Excitation table plays very important role in designing of the counters. That is designing of the synchronous counter. We must know the excitation table. First, let's see what is truth table. What is truth table in flip-flop? Generally, truth table gives the relation between input variables and output variables. In flip-flops, truth table shows how flip-flop reacts to produce next state for various input combinations. Now let's see what is excitation table. What is excitation table in flip-flops? The excitation table shows the minimum inputs required to produce next state when present state is known. It is also defined as minimum inputs required to excite the flip-flop from present state to next state. So now I will discuss the excitation table for SR flip-flop, how to derive excitation table of SR flip-flop from the truth table. Here we can see that there are two tables. This is known as truth table. This is a truth table for SR flip-flop. Here Qn represent present state of the flip-flop and Qn plus 1 is next state of the flip-flop. So now let's see how to derive excitation table from the truth table. So here in excitation table, here we can observe that Qn and Qn plus 1 is written first, then inputs will written on right side. Similarly here S and R are written on left side, Qn and Qn plus 1 are written on right side. So here Qn is same, that is present state, Qn plus 1 is next state. So as per the definition, here we can see that minimum inputs required to excite the flip-flop from present state to next state. So in excitation table, here we can observe that present state is 0, next state is also 0. So what is the value of S and R so that the flip-flop will excite from 0 to 0? Now let's see the same condition in case in truth table. Here we can observe that the present state is 0, next state is 0 in this row. Similarly here also we have present state is 0, next state is 0. Now we'll see the corresponding inputs. The corresponding inputs are S is 0, R is 0, and here S is 0 and R is 1. So S input is same, that is S is 0, but R value is one side it is 0, one side it is 1. So for both the cases, Qn and Qn plus 1 are 0, 0. So I can write S is 0 on both the sides. So I will write S is 0. R value is either it is 0 or 1. So I can take it as don't care. Don't care means the value is either 0 or 1. So I can write in place of 0 or 1, I will use it as don't care. That is, for R is equal to 0 or 1, the state of the flip-flop will excite from 0 to 0. So I can say that this first row is derived from this row of the truth table and this row of the truth table. Now let's see 0 and 1. The present state is 0, next state is 1. So for what values of S and R, the present state is 0 and next state will be 1. We'll see the similar condition in truth table. So here we can see Xn is 0, that is present state is 0 and next state is 1. Only for this row we can observe present state is 0 and next state is 1. The corresponding inputs here are S equal to 1 and R equal to 0. Let me write S equal to 1, S equal to 1 and R equal to 0. So this row is derived from this one. Similarly, when present state is 1, next state is 0. That is exciting from 1 to 0. Let's see for what values of S and R this condition will occur. That is, Qn is equal to 1 and Qn plus 1 is equal to 0. Here we can see, here we have Qn is equal to 1 and Qn plus 1 is 0. Only for this row, Qn is 1 and Qn plus 1 is 0. The corresponding inputs are S equal to 0 and R equal to 1. So S equal to 0 and R equal to 1. So this row is derived from this row, from the truth table. Next, Qn is 1, Qn plus 1 is 1. So here we can observe that here we have Qn is equal to 1, Qn plus 1 is equal to 1. Similarly, here also Qn is equal to 1 and Qn plus 1 is 1. So for two rows, the value is same. So the corresponding inputs are S is equal to 0, R is equal to 0. Here S is equal to 1, R is equal to 0. So R is equal to 0 in both the cases. Let me write R is equal to 0. In one case S is 0, in another case S is 1. So I can take it as don't care. So now in this table, these two rows are not applicable as the next state is XX. So we cannot find next state as XX. So we will ignore these two rows. So this is the excitation table for SR flip-flop. Now let me write the excitation table for JK flip-flop. Now let me explain the excitation table for JK flip-flop. Now let me derive excitation table for JK flip-flop from JK truth table. This is the truth table. Here same Qn is present state, Qn plus 1 is next state. Here Qn is present state and this is next state. So here the first condition is Qn present state is 0, next state is 0. Let's find the same condition in truth table. Here we can observe that present state is 0, next state is 0. Similarly, here also present state is 0, next state is 0. Let me compare this row and this row. In both the cases, J is 0, but here K is 0 and here K is 1. So J is 0, J must be 0 here, and K is either 0 or 1. So here we should write don't care. That is X value either it is 0 or 1. Similarly, so the first row is derived from this row and this row. Similarly 0, 1. So here we have 0, 1 and here we have 0 and 1. The corresponding inputs are, we have to check these two rows now. Here J is 1, here also J is 1, therefore J will be 1. So here K is 0, here K is 1. So it must be don't care. So thus this row is derived from this row and this row. Similarly, the Qn is 0 and Qn plus 1 is so Qn is 1, Qn plus 1 is 0. So here we have Qn is 1 and Qn plus 1 is 0, and here we have Qn is 1, Qn plus 1 is 0. Let me compare this row and this row. So here J value is 0, here J value is 1, K value is 1, K value is 1. So K value is 1 and J value must be don't care. So thus this row is derived from this one and this one. Next one is when Qn is 1 and Qn plus 1 is 1. That is, here we have Qn is equal to 1, Qn plus 1 is equal to 1. Here we have Qn is equal to 1, Qn plus 1 is equal to 1. So we should compare this row and this row. So here J is 0, here J is 1, K is 0, K is 0. So K is 0, J is either 0 or 1. So it is don't care. So thus this is the excitation table for JK flip-flop. Now let me derive the excitation table for D flip-flop from truth table. This is the truth table of D flip-flop. This is present state. This is next state. Similarly, here this is present state and this is next state. So the present state is 0, next state is 0. So here in truth table, here we can find present state is 0, next state is 0. The corresponding input is D equal to 0. So here D must be 0. When present state is 0, next state is 1, that is 0, 1. Here we can observe 0, 1. The corresponding input D is 1. So it should be 1. When it is 1, 0, so here we can see 1, 0. Corresponding input is 0. 0 should be written here. Here it is 1, 1. So here it is 1, 1. The corresponding input is D is equal to 1. So this is the excitation table for D flip-flop. Now let me derive the excitation table for T flip-flop. So this is present state, next state, this will be present state, and this will be next state. So toggle flip-flop, when it is 0 0, here we can find 0 0, the corresponding input is 0, 0 must be written here. 0 1, here we have 0 1, corresponding input is 1, 1 must be written here. Similarly 1 0, here we have 1 0, corresponding input is 1, 1 must be written here. And when it is 1 1, that is 1 1, corresponding input is 0, 0 must be written here. So this is the excitation table for T flip-flop. Thus we derived excitation table for all the flip-flops from its truth table. Thank you for watching.